What research is being done on the frontal lobe in schizophrenia? Have you ever wondered how the brain's structure affects mental health? Today, we are focusing on the frontal lobe and its role in schizophrenia. Research in this area is revealing fascinating details about how this part of the brain functions and what happens when things go wrong. The frontal lobe, especially the prefrontal cortex, is vital for decision-making, emotional regulation, and social interactions. In individuals with schizophrenia, studies show that there are noticeable changes in the structure and function of the frontal lobe. For instance, many people with this condition have reduced gray matter volume in both frontal lobes. This reduction is often linked to symptoms like hallucinations and cognitive impairments. Functional imaging techniques, such as positron emission tomography and functional magnetic resonance imaging, have provided insights into blood flow and metabolic activity in the frontal regions. Researchers have found decreased dopamine releases in the dorsolateral prefrontal cortex, which is crucial for cognitive control and working memory. This may explain some of the cognitive challenges faced by those with schizophrenia. Another area of interest is the connection between the frontal lobe and insight. Many individuals with schizophrenia struggle to recognize their symptoms and the need for treatment. Abnormal blood flow in specific regions, including the middle frontal gyrus, has been associated with this impaired insight. Suicidality is another serious concern in schizophrenia, and research indicates that dysfunction in the prefrontal cortex may increase the risk of suicidal thoughts and behaviors. Lower activation in certain prefrontal regions correlates with these thoughts, suggesting that frontal lobe dysfunction can impact impulse control. White matter connectivity is also being studied. Researchers have observed reduced network efficiency and structural integrity in regions like the medial and paracingulate gyri. These disruptions can affect emotional regulation and cognitive processes. Interestingly, they are also related to metabolic syndrome in patients treated with antipsychotics. Social perception is another critical aspect affected by frontal lobe dysfunction. Studies using event-related potentials have shown that individuals with schizophrenia often have difficulties with facial recognition and emotional processing. This can significantly impact their social interactions and overall quality of life. Recent research is also looking at how the frontal lobe networks interact with other brain regions. For example, enhanced connectivity between the frontal lobe and visual networks has been linked to milder negative symptoms. This suggests that the dynamics within the frontal lobe may influence the severity of symptoms experienced by individuals. Finally, abnormal blood supply to the frontal lobes has been documented, with lower oxygenated hemoglobin levels indicating metabolic disturbances. These disturbances may underlie some cognitive and emotional symptoms associated with schizophrenia. The practical applications of this research are promising. Scientists are developing targeted brain stimulation therapies aimed at improving insight and cognitive function by modulating frontal lobe activity. Understanding these abnormalities also guides pharmacological approaches to address dopamine dysfunction and white matter integrity, potentially leading to better treatment outcomes. Overall, research on the frontal lobe in schizophrenia combines structural imaging, functional studies, and neurophysiological assessments. This work is crucial in clarifying how frontal lobe abnormalities contribute to the core symptoms and complications of schizophrenia.